This is Algebra 1, Chapter 1.6. We're going to talk about relations, or relationships in math. So, first thing we have to do is do a couple of these definitions here. Get these out of the way. What's the coordinate system? What's the coordinate system, guys? Anybody have a guess? Matt?
Set of coordinates on coordinate plane.
A coordinate plane. Okay, coordinate system, a coordinate plane. Okay, I can go with that. Or a plane. The coordinate plane. The XY plane. What do we call that? The XY plane. Not an aeroplane, but an XY plane. Mike?
There's an X and Y axis.
Yeah, it has an X and Y axis. And that X and Y axis will intersect. So how about the intersection of two number lines? The intersection of two number lines, we call those the X axis and Y axis. Now, we also talked about the coordinate system having coordinate pairs or points. Those are called ordered pairs. Ordered pairs, what do they look like on our XY plane? What comes first?
The X.
The X comes first and then Y. You always graph X first and then you graph Y. The ordered pair is made up of your X coordinate and your Y coordinate. Your X coordinate follows the X axis. Your Y coordinate follows your X coordinate follows your X axis because your X axis is your horizontal movement. That's your horizontal movement. Your Y coordinate follows your Y axis. Your Y axis is your vertical movement. So the coordinate system, guys, maybe we should even go back up to here. And if I draw it, that's what it looks like. Our two number lines intersecting. We have our X axis and you have your Y axis. The scale on your X and Y axes are what you make it to be. You can go by ones, you can go by twos, you can go by tens if you want. Or hundreds, doesn't matter. So, what we would do is if I had an ordered pair, and we're going to get there, is if I had an ordered pair of, where are we here? 1, 2 in the middle there. I could plot that very easily by going 1 to the positive direction of X and 2 up. And there's your point on the coordinate graph. I'm assuming most of us have plotted points before. We did it before in one of our lessons from the pre-chapters where we made our scatter plot graphs, right? We just plotted our data. We've done that before. The biggest thing about this particular lesson is the relation. What is a relation? Your ordered pair. Your ordered pair is a type of relationship. Relationship, maybe better to say, is something / rule that connects inputs
Oh, yeah, that's right.
and outputs. So it's something. It could be a rule. It could be some kind of
Anything with
Anything that has a connection, yeah. That connects inputs to outputs. That's considered a relation. And it doesn't matter what it is. Ordered pairs, like the one we had with 1, 2, basically the relationship is, if I put a 1 in, I will get a 2 out. That's a relationship. It always will happen. If I put a 1 in, I'll get a 2 out. Boom. We established that there's a rule. Okay? Now, the one way we can show a relation or relationship is by a mapping. And a mapping, guys, takes your inputs and your outputs. Inputs, outputs. We will call these domain and range soon, I think, today or tomorrow. So we don't really know what those are. We will learn those definitions in a little bit. But it basically takes inputs, no matter what they are, and connects them to outputs. It's like a map. And this map just connects them together. So the relationship is, if I put a 1 in, I will get a what?
7.
7. If I put a 3, I get an 8. If I put a 4 in, I'll get a 9. That's the relationship, but the mapping allows me to visualize what's going on. So yes, now here are the definitions, domain and range. What's the domain? It's your inputs. Domain are those inputs. Domain, guys, if you think of your domain is your house. Yes?
Yep.
You control what goes on.
Well, not
Okay, not necessarily because your parents technically have it. Okay, I get it. Your friends come over, you kind of are the leader, right, at your house. You kind of set the tone saying this is what we're going to do or we can do at my house. So, your domain are the ones that you control. Or, I say maybe not, because we control them. Okay. Let's back up and say then our range are the outputs. Trying to make this as simple as possible. So we got opposites, we got inputs, we got outputs. You got ones you control, and then the ones that you don't really control. I'm not trying to think of a better word for that. If you don't control it, what can we say?
It will go into chaos.
Dependent?
Yeah.
I think dependent is a good one. I like that over here. It's my dependent variable. So maybe instead of control, put a little slash there and say independent. Because at your house, you're more independent than, say, someone else's house. You're more free to do the things you want because you know what you can do. So how about we say that the domain, guys, is your independent variable, the one you control. The range is dependent because it depends on what you put in. Now, someone probably could go back to this stuff here and say, hey, I want a 7 to come out. So I can control the fact that I'm going to put a 1 in to get that 7. But unfortunately, that's not how it works. It's still our independent variable because it depends on something else. It depends on you putting a 1 in. Okay? So, yes, that means instead of calling that my inputs, I now can call that my domain and range. So those can be interchanged. Or independent, dependent variables. So usually, our domain are the x's, and y is the range. So my first example that I want to do with you guys here is to take the set of points, which is one form of data display. And I want you to, number one, make a table. Number two, graph that on an XY plane, and then make a mapping. So the first thing I'll do is make a table. What I mean by a table, I mean an XY table, or XY chart, or a T chart, I call that sometimes, where I just put all my X's first and then my Y's second. What's the first point?
2.
2,
2,
5. And then it goes to negative 3.
Negative 2.
Oh, sorry, negative 2. 3. Next, 5, negative 2. And the last point, negative 1, negative 2. Is everybody okay with making a T-chart? Not too bad. This T-chart, guys, can lead us to a graph if I have it there, or the points themselves. Let's graph it. I think it'd be a good idea to go by ones. I would be as consistent as possible with your tick marks. It'll make your life easier.
Yeah, you only have 4 on the left.
That's okay.
Oh.
Does it matter? Consistent, what I mean by consistent would be the gap. The spacing of your tick marks, you want to be as close as you can. If you're on your white lined paper, you can use the lines to your advantage. If you're using graph paper, obviously use the grids.
So why do we have to do mapping and a table when it's basically the same thing? Because mapping is just input-output.
Yes, but the mapping connects them.
Right.
And so therefore, and I'll show you a slight difference here.
Well, in the table,
There's going to be a slight difference for mapping. We'll get there. So let's plot these points. 2, 5. Negative 2, 3. 5, negative 2. And negative 1, negative 2. Okay, so everybody's okay with the graph, I hope. They're just plotting points. And then the mapping, guys. Now we're going to go here.
Oh, I remember why.
Now we're going to have our domain, our range. And so the difference between the table and the mapping is I'm not going to repeat my numbers.
That's right.
So I go to my x values. Is there anything that doubles up?
No.
No. So I have to put 2, I have to put negative 2, a 5, and a negative 1 in. Does everybody see that? Those are all my x values that are going in.
Yep.
On the way out, for my range, though, we are actually doubling up on
Negative 2.
negative 2. So we need a 5, I need a 3, and I need a negative 2.
Then you just draw the 1 and the 5.
So now I just have to connect them. 2 goes to 5. Negative 2 goes to 3. 5 goes to negative 2. And negative 1 also goes to negative 2. That is a mapping. So, would you guys be able to, as well, if I gave you a mapping, make a graph, make a table, and state the points? So be ready, guys. If I gave you any of the 4, you could write the other 3. That's all fair game. We already talked about this one, independent variable and dependent variable. It's an independent variable because you are free to do what you want. Your x values are that independent variable. You control. You're independent. You're in control. Your dependent variable is the y. We've already talked about those, so I'm not going to go into more depth on there. And so now we only have to do is decide on the three different problems we have here. Identify the independent and dependent variables for each relationship. So, the dance committee is selling tickets to the Fall Festival. Fall Fest. The more tickets that they sell, the greater the amount of money they can spend for decorations. So, I want independent and dependent. Someone give me a reason, which one is which, and a reason why. We said the dependent is the money for decorations, decor, because do they know exactly how much money they have?
No.
Yeah, yeah.
But wouldn't
No.
it also be the amount of tickets they sell for a dependent variable? Because they don't know how many
No.
tickets they're going to sell?
Well, let's just think of this. The money for the decor is based off of
How many tickets?
how many tickets. So therefore, tickets
Would be
tickets will change. That's our independent. The more tickets, the more money. So the money depends on the tickets. So the tickets are the independent. The money is the dependent because it depends on something else. Part B, generally the average pizza. Wow, I'm hungry, huh? The average price of going to the movies has steadily increased over time. Which ones are independent and dependent? Which one's independent? Which one's dependent? Price of movies increasing over time. Chuck. Steady increase of what?
time.
Price would be what? Average price being the independent. So who depends on who?
Price depends.
Does the price depend on time, or does time depend on price?
Price depends on time.
Fritz?
Time.
Right. Time, guys, will keep marching on, but as more time goes on, the price will go up. So the more time that passes, the higher the price. Are we seeing that there's a slight difference? Now, if this would have been something on the lines of the more you pay, the longer you get to stay in the movie theater, then the price would be the independent and the time would be dependent. You see that?
Yeah.
Because the more money you pay, the longer you get to stay. The more time you get. So therefore, the time depends on how much money you want to put up front. And the last one here for this, the air pressure inside a tire increases with the temperature. Mike?
The temperature is independent and air pressure is dependent.
Mike says temp is your independent, dependent is the pressure. Is that correct? Because if the temp changes, the pressure changes. It's not the other way around. And the last two things we have to talk about, these aren't the best because I had to draw them freehand. Describe what's happening in each of the graphs.
As time increases.
Okay, I like it. Time increases, your distance will
There you go, Pac-Man. You know,
increase. Everybody hopefully sees that time is marching on, distance is going on. But is it always happening that way? Overall, the distance is increasing.
No, it's not.
So what can we say is happening about here?
Generally, time increases.
What's that?
Or generally-
They have bad gas mileage.
Bad gas mileage. I don't think this is gas mileage. This is not. Gas mileage would be miles per gallon. That wouldn't necessarily be here. It says this could be miles per hour.
Yeah, stop.
Maybe if you put them together. What do we got over there, Park? Yeah, they stopped here, guys. Is my distance increasing right here? No, the distance does not increase, but time is still going on. Then all of a sudden, we go again, and then we stop. And then all of a sudden, it kind of takes off again.
Are we gonna have to do the things where we like write?
You're gonna explain. You very well could explain the situation. That's basically what we're doing. The next one, change in income. Overall, we can say what here?
As time increases, your income.
As the time increases, your income increases. What could be happening about here?
Steady, 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 then it'll go.
It stayed steady, maybe even a little dip.
Went on a vacation.
You went on a vacation. Maybe you lost one of your income streams. Maybe you lost a job for a little bit, so your income went down just a little bit. But then maybe you picked up another job and it went up again. Okay? You got to think of watch your axes and figure out if I'm talking about time. Time's not going to stop, guys. Time keeps going. So whatever happens, it could plateau. It could end up. What if it went like this? We could definitely see then that here we plateaued. Something happened. We stopped making money, right? But here we started with like no income and quickly rose up to it, and all of a sudden it really shoots up.
Stock market crash anyway.
Okay?
It would be a lot.
So there's different situations that could happen. Your job then is to come up with a situation that would match that graph. Homework is page 43, 9 through 30, every 3. Have a great day.